Hi, hello, welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos and published in a public domain like YouTube. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me and sparking me for creating these kinds of technical videos in a public domain, and his regular contribution as well as his support, moral support, it is very good. And I would like to thank Almighty, my friends, followers, my dear students and subscribers for their continuous support and encouragement. I would like to say that today's topic of interest is governance. First of all, we should know what is meant by governor and where it is used. The application of the governor is very simple in nature. Wherever the machine should run at constant speed, if the load may vary, if the machine is supposed to be rotate at a constant speed, there we can use governors. For your information, if we are having a home hold power producing device, that is generator, if it is switched on, what happens if we put more number of lights? The generator itself operated in a huge rpm in order to produce the same power. So the more quantity of fuel is getting in order to contribute or produce the same power, where the governor type is power governor. Okay, it governs the power. And whereas if there is no load, what will happen? It is the engine is rotating at a very slow speed or a normal condition, where the power is not enough. Sorry, power is more enough for producing or making a lights or anything. So there we can use governor. In stationary engines, there is a governor. Similarly, in the power plants, the turbine should be operated at a constant speed. For the constant speed, the flow may be adjusted. Okay, if we want to have a more load, what will happen? The speed will get reduced. Therefore, more quantity of steam is required in order to maintain the same speed. There, the speed governor is used. So this is the application of the governor. Wherever the speed or a power is to be constant, wherever the criteria should be a constant, we have to maintain a device which is called as a governor, I say. Okay, first of all, we have to know the difference between the governor as well as the flywheel. In stationary engine, flywheel is also there, governor is also there. The purpose is, we know that the engine is producing a cyclic fluctuation, because in a four stroke engine we have a four strokes: suction, compression, power, exhaust. In only one stroke called power stroke, we are having a power. In order to store the huge power and in order to supply the huge power getting in a one single stroke to the other three stroke, we need a device called a storing device, which is called as a flywheel. So flywheel minimize the fluctuation of the speed. So this is our understanding. Flywheel minimize or reduce the fluctuation of a speed, whereas the governor, which maintains the speed, which maintains the speed. Okay, therefore the flywheel is different and the governor is different. Here, my first thing is to know or is to give a clarity about the flywheel and the governor. First, the flywheel is used to reduce fluctuation of speed, maintain the torque or turning moment during each cycle. So that is the function of a flywheel. And the main purpose is to absorb energy. The supply is more and demand is less or requirement. We can say demand or a requirement, whatever may be. If supply is more than the demand, we have to store. If the requirement is more than the supply, the stored thing should be released. If here the energy is stored, therefore the energy is released. It does not maintain constant speed. So this is the important point. The flywheel does not maintain the constant speed. It minimizes the fluctuation in the speed only. And also it does not controls the speed variation caused by varying load. Where the governor does these two things. Governor will maintain constant speed and it controls the speed variation caused by varying load. That is why the governor is having a capacity to maintain the speed of an engine within specified limit. If our limit is set at say 1000 to 1500 rpm, whatever the load can vary or whatever the load can vary, it can manipulate the speed from 1000 to 1500 rpm and it will make that load at the maximum possible. And also it maintains driver in constant speed. Yes, it can be done. And here I would like to give the types of the governor which we are having. Majorly, the governor is classified into two types. One is centrifugal governor, the another one is inertial governor. The inertia governor, the inertia of the mass is maintained, whereas in the centrifugal governor, due to the centrifugal force, due to the centrifugal force, it controls the or it maintains the constant speed. In centrifugal governor, we have two types. One is pendulum type and another one is loaded type. In pendulum type, we are having only one governor that is called watt governor. No dead weight. So that is very very important. Watt governor, there is no dead weight. Whereas loaded type governor is having two types. It is further classified into two types. One is deadweight governor and another one is a spring loaded governor. The deadweight governor, it is divided into two types. One is porter and another one is royal. These two governors are a modified form of a watt governor. In watt governor, I said earlier, there is no dead weights. In the deadweight governor, there is some dead weights. We know that we can remember by the name itself, porter. In all the railway stations, we have a porter or a weight lifter. He can lift in a weight. He can lift some weight. So, therefore, porter governor, it is having some weight. By the means of the story, we can easily catch that the porter is having is always carry a weight. Therefore, porter governor is having weights. In the same type, the royal governor, the fly ball is used as a weights. Fly ball is used as a weights. When there is a P and P, then porter and royal. Therefore, both governors are deadweight governors. And the spring loaded governor, the governor like Hornell, Horton, Wilson, gravity governor, Pickering governor are the types of spring-loaded governors. Here, I would like to give an introduction about inertia governor. In inertia governor, the position of balls, according to the position of balls, forces are set up in an angular acceleration as well as the deceleration of the given spindle and addition to the centrifugal force of the ball. So that is called inertia governor. So the ball is positioned wherever the speed is more, the ball is positioned according to the ball force, it can be manipulated. Therefore, inertia governor is faster than centrifugal governor. That means the time to maintain the constant speed, according to the time to maintain the constant speed, inertia governor can make the speed in very faster manner. It becomes a stable one. Whereas in the centrifugal governor, it is something different. So first one, the spring-loaded governor. In the spring-loaded governor, we have a Pickering, Hartnell, Hartung, gravity, Wilson, Hartnell, Wilson. The spring is used in order to improve the governor action. In order to maintain the centrifugal governor into an inertial governor, the spring is used. According to the spring stiffness, the governor response will be there. If you can see the name itself, the spring, we have in the spring we have P is there, H is there, G is there. That means P for Pickering, H for Hartnell, Hartung and Wilson Hartnell and G for gravity. And next one, how to remember the Proel governor? The Proel, P-R-O-E-L-L. If you capital L, L, E, L, L, and it will tends to give an explanation about extension of two balls. Extension of two balls is there. Therefore, flying balls, that means extension of balls, two balls means we have used two balls. Extensively, two balls are used. First of all, in the watt governor, so this is the simple sketch of the watt governor. So this is the sleeve, this is the weight, and this is the spindle, and this is coupled with the driver shaft. The driver I am saying, whichever want to maintain a constant speed, that is called as a driver. The driver has to be attached here, and this is the pivot point. So this is the pivot point, and if the speed of rotation is there, then according to the masses, these are the masses. These two are the masses, m1. Both are having same mass. If the mass is rotating as per the Newton's second law, mass into acceleration will give the force. So the force is called as a centrifugal force. This centrifugal force, what will tend? It tend to move the ball in this direction. What will happen if the ball is moved? The links are having same length. The links are having the same length. The length won't vary, then the sleeve comes up or down according to the force acting on the governor. So like that, the height of the governor is very important in terms of a watt or a Proel. According to the height and the speed, the height and speed are inversely proportionals, and height h is inversely proportional to n square. Therefore, height is very important. If the height is low, then the speed is more. Square times of more. If I say if the height is reduced by 2 times, the speed is increased by 4 times. Like that. How we get this formula? We know that the relation height is equal to gravity into angular velocity square. We know that angular velocity omega is equal to 2 pi n by 60. If we simplify this, we get a formula 895 divided by n square. Therefore, h is the height. Therefore, it is indicated in the meter. Here, I will give an simple relation between the two variables like the speed as well as the height. If the height is reduced, what will happen? If the height is reduced, the speed is more. That is the square times of the more. We have here, you can notice this n and h. So h is directly proportional to, inversely proportional to n square. Therefore, we say h is directly proportional to n power minus 2. If height is more, then the speed is low. If the height is down, then the speed is more. Thank you. And next is the Porter governor. It is the modified form of what governor? How it is modified? The dead weight is added. Therefore, the dead weight on the sleeve. Say, this is the sleeve. This is the sleeve. In the sleeve, we can add a dead weight. There is a dead weight in the sleeve, therefore, the centrifugal force will become very low. And also, it would maintain more sensitivity, having more sensitivity. Here, the relation of here also the relation of h and n is very important, and this is due to the weights. This is the weights where capital W is the weight of central load and small w is the weight of each ball, and alpha and beta are the upper and lower link to the verticals where n is the speed and h is the height of the governor. And we know that the q, small q is equal to tan beta by tan alpha, and this is the constant. This is the constant. Q is the constant where the relation becomes n square is equal to small w plus capital W by 2 into 1 plus q divided by small w into 895 divided by h. And next one is the Pickering governor. It is the form of a spring loaded governor. Mostly it is used in driving a gramophone. It is mostly used to driving a gramophone. And the next one is a very important topic, the sensitivity. Sensitivity is the difference between two speeds. That is called sensitivity. Difference between two speeds means what I am saying, if the governor is to be rotating at say a constant speed of 1500 rpm, according to the load conditions, it may go to 1600, 1400. Therefore, the range of the speed to the mean of the speed, which is called as a sensitivity. Here, the range is n1 minus n2, where the mean is n1 plus n2 divided by 2. Therefore, this is called as a sensitivity. Therefore, the difference in speed divided by mean speed, which is called as a sensitivity of the governor. There are different kinds in terms of angular velocity and in terms of normal velocity and in terms of the speed is given. Therefore, their definition is same. The difference of the speed to the mean speed. And next one is the stability. Stability is very important factor in the governor. How stable it is, what is the working range of the governor, this is the important one. So the stability implies these things. When the governor is stable for every speed within the working range, there is a definite configuration. When there is a definite configuration, it will become stable. If you are not able to define the configuration, it will become unstable, and it is having infinite configuration. It is called as an isochronism. So this is the difference between stable, unstable, and isochronism. Where the stability, there is only one radius of rotation. Stability means there is only one radius of rotation of the governor balls at which of the governor is in equilibrium condition. Therefore, the stability of the governor implies the equilibrium condition. When it is having, instead of definite configuration in the stability, if there is an infinite configuration, what will happen? It is having an isochronism. Isochronism means the stage of infinite sensitivity, which indicates that when the equilibrium speed is constant and the range of the speed is zero, the sensitivity, if the range becomes zero, so this is the range, so this is the mean, and this is the range. If the range becomes zero, zero by anything is zero. Therefore, the range of the speed is zero for all radius of rotation of the ball within the working range, and neglecting the friction, the stages are having infinite sensitivity. For the stable governor, if an equilibrium speed is increased, the radius of governor balls must also increased. Where in isochronism, it won't happen. In hunting, what is meant by hunting? The constant fluctuation of the speed. If I am saying what this hunting means, if I am saying my governor is running at 1500 rpm, say constantly 1500 rpm. If my load is little bit small and the speed becomes, instead of 1500, the 1501, and the immediate response of the governor is there in order to maintain the 1500 rpm. So more sensitivity. Hunting means more sensitivity. It is too sensitive. So a small variation in the speed can be calculated and can be manipulated by means of a hunting governor. And also hunting is very very dangerous also, because a huge fluctuation is there. The engine speed is fluctuate continuously above and below the mean speed. This will cause the governor and make it too sensitive. Here I would like to indicate how the isochronism is remembered by means of a mnemonic code. It having CRN, that means constant radius and speed even though the load is fluctuated. So that is called as an isochronism. And this is the controlling force diagram. In every governor is controlled by an equation called the centrifugal force is equal to centrifugal force on the ball, which is equal to AR to B. AR and B. Here the A and B are the constants. A and B are the constants. R is the radius of the rotation. Therefore, here our understanding is the centrifugal force is directly proportional to R. The centrifugal force is directly proportional to R. Therefore, if F is directly proportional to R, the proportionality constant become a constant. Therefore, we can say it is become in isochronism. If FC is directly proportional to R, we put a constant instead of the proportionality constant. We put we put instead of proportionality constant, we put an acceleration A as a constant again. Then it will become isochronism. What is meant by isochronism? The constant speed and constant radius. The radius is constant for all speed. Therefore, if the radius is constant, the force on the ball is constant and it becomes isochronism. Iso means same. If if the F is equal to AR plus B, therefore the constant is added in the equation. If the constant is added in the equation, it will become unstable, too sensitive. It will become too sensitive. If the constant is neglected, if the constant is minus, if the constant is minus in the minus direction, it will become more stable. So, by this information, I would like to close the session of the governor. I hope that I have given enough detail about the governor. Thank you for your patient watching and listening. Thank you all. If you have any doubts, let me know in the comment section. With that, this is Santhosh. Thank you.